In this video, I will explain the necessary processes that must be taken to properly determine if a line is parallel or perpendicular to another line based on its slope, and how to find the slope of the other line. Also, I will show how to find the equation of another line when given the slope and 2 points that the line goes through. When two lines are parallel, their slopes must be identical. This is because if they have any other slope, they will at some point intersect. The rest of the equation does not have to be the same as long as the slopes are. So the lines y equals 5x plus 2 is parallel to the line y equals 5x minus 10, as shown in the image. The two following lines are not parallel. Y equals 4x plus 3 and y equals negative 4x plus 3. This is because the first slope is 4, but the second slope is negative 4. To find the line perpendicular to another line, you must find the opposite reciprocal. So when two lines are perpendicular, it means that they intersect at a 90-degree angle. In order to find the opposite reciprocal, you must first find the additive inverse. So the additive inverse is the number when added to the original number results in 0. So the additive inverse of 4 is negative 4, because 4 plus negative 4 equals 0. Or the additive inverse of negative 8 is 8, because negative 8 plus 8 equals 0. So then you must find the reciprocal of the additive inverse. So to do this, you just change the numerator into the place where the denominator usually is, and the denominator into the regular place of the numerator. So this would result in like negative 4 becoming negative 1/4. So to find the opposite reciprocal of 7, you would find the additive inverse, which is negative 7, and then the reciprocal, which would make it negative 1/7. And then to find the opposite reciprocal of negative 1/2, you'd find the additive inverse, which is positive 1/2, and then the reciprocal, which would be 2. So if you are given 2 points and the slope of the line, then you can find the equation of a line. You cannot directly go into slope-intercept form, but you can go into point-slope form and then convert into slope-intercept form. So point-slope form is y minus y1 equals m times the quantity of x minus x1. So y1 is the y-coordinate, x1 is the x-coordinate, and m is the slope. So all you do is you plug in the y-coordinate into y1, the x-coordinate into x1, and then the slope into m, and then you can convert into slope-intercept form. So here's an example on how to use all of the principles that have been taught so far in the video. So find the equation of a line that is perpendicular to the line y equals negative 5 plus 3 and goes through point 7, 6. And the equation must be in slope-intercept form. So first find the first slope, which is perpendicular to the slope of negative 5. So just find the opposite reciprocal of negative 5. So first find the additive inverse, which is 5, and then find the reciprocal, which is 1/5. So 1/5 is the slope of the line that we will graph. And then just plug it into the point-slope equation. So you plug the slope in and the x and y coordinates. So this results in the first equation shown. And then you distribute 1/5 to x and negative 7, which results in y minus 6 equals 1/5 x minus 7/5. You then add 6 to cancel out the negative 6 on this side, and then you add it to the negative 7/5 on the other side. So this results in the final equation being y equals 1/5 x plus 4.6. So this would be this line, and you can see that it is perpendicular to the original line and goes through the point 7, 6. So here's the next example. So find the equation of a line that is parallel to the line y equals 7x plus 4 and goes through the point 2, 6. And this must also be in slope-intercept form. So first, you don't have to do any work to find the slope because it is already given because the two lines are parallel. So the slope will remain as 7. All you have to do is now is plug into point slope form. So just put the x coordinate where in x and the y coordinate in y, which results in this. And the first step is to distribute the 7 to the x and the -2, which results in y minus 6 equals 7x minus 14. And then you just add 6 to cancel it out on that side, and then you have to also add it to the other side. So that would result in the final equation being y equals 7x minus 8. So then this would result in this line, and you can see that the two lines are parallel and it goes through the point 2, 6. So the final example is a little bit more challenging, but it incorporates all of the principles that have been learned and one new one. So find the equation of a line that goes through the point 1, 1 and is perpendicular to a line that goes through the points 2, 4, and 5, 7. So since we have 2 points that are graphed, you can find the slope of the line by just doing rise over run, but I will show a new technique in this video that will be easier in the long run. So all it is if you plug the 2 points into the equation y2 minus y1 over x2 minus x1, that will give you the slope of the line. So the 2 points that were given for the original line are shown with the x1, y1, x2, and y2. And so all you have to do is plug in 7 as y2, 4 as y1, 5 as x2, and 2 as x1. So it would result in looking like 7 minus 4 over 5 minus 2. And then just calculate that, which is 3 over 3, or 1. And then since the line that we will be graphing is perpendicular, all you have to do is find the additive inverse, which is -1, and then the reciprocal, which equals -1, because it would just be -1 over 1. You flip that, it remains the same. So just plug that into point slope form now, and it would be y minus 1 equals -1 times the quantity of x minus 1, which is a little bit of a mouthful, but so then you can just distribute the -1 to the x and the -1, and this results in y minus 1 equals -1x plus 1, and that's plus 1 because the negative from the slope and the negative from the coordinate cancel out, and it becomes positive. So then add 1 to both sides, which cancels it out on that side, and then just add it to the other side, and so it would result in y equals -1 x plus 2. This can also be written as y equals -x plus 2. And then the line, when graphed, should look like this.